Okay, so yesterday we started looking at the area under a curve, which was this one, and we found out that if we consider the f of x being our function, that the g of x becomes is our x-axis. If you're looking at this one, we looked at the f of x is a parabola. Still, we've got our g of x. But can you see the difference between this function and this function? The area underneath the curve means that we're going to end up saying f of x minus g of x, like I do in this sum right there. And then for this one, you have the upper function, in fact, being the g of x, which is the x-axis, and the f of x being below it. And if we resolve the area for this one, we end up with that g of x being a 0. So y is equal to 0. And for this one, our g of x is still 0, but we have to isolate that negative on the outside. So for the area above the curve between the g of x and the function, it becomes a negative area. Whereas in this one, we have a positive area, which is the area below the function. So what we want to move on to today is just a slightly more complicated example of calculating the area between an x-axis and a function. And if you go with me to page 134 in our Hazy textbook, exercise 5B, number 1D, what you find in that space, I'm just going to reproduce it here for us, is little x-axis, and I'm going to just draw what's almost a replica, like this one. You've got a point that they indicate on the diagram where they say this number is 1. This number is unknown at this point, and they're asking us to calculate this little patch right here. So I'm coloring it in this luminescent green that you can see over there. So if we're looking at that function, the first thing you want to notice is actually that function, it is given to us as y is equal to x cubed minus 4x. So the first thing we want to resolve is what is this little point here that we are going to be able to say the region that's enclosed by this area. So if this one is A and this one is B, what is that number? So it's the intersection between our function and our x-axis. So in order to find that, we need to resolve what's the value of our function when y is equal to 0. So one of the things you probably would notice, I'm just going to rewrite it over here when I have more space, is that you've got a common factor. So if we take out that common factor, so we've got y is equal to, we take out our x, we end up with x squared minus 4. If you're looking at our function before we can resolve it any further, you might notice that this is the difference between two squares. So if we just take our plus and our minus, the square root of x and the square root of 4, there's our two numbers. At this point, we can use our null factor, so the possible value for x, wherever the function intersects with our x-axis, we can see x could be equal to 0, or x could be equal to minus 2, or x could be equal to positive 2. So if we're looking at our function, our picture here, we've got our negative 2 over here, but we're not really interested in that for this sum. We've got our 0 over here. Again, we're not interested in that whole space. We're just interested in this number, which is this one right here, the B point, which is equal to 2. Okay, so we've established that our function, which is now here, and the little green zone, which is over here, is the space that we want to find out the area for. We've got the point of intersection between our function and the x-axis. So if we're looking at this space, it's going to fall below the x-axis. So making this zone, the space where this is the upper and my actual function forms my lower boundary. So if I'm going to write my function down and just say, I've got my x-intercept that matters, and I'm going to say the area that I want to focus on is going to look, there's my integration sign. I've got the two boundaries of A and B on the x-axis for our shaded area, which is from 1 to 2. So it's just that tiny little space, making my upper function, my lower function, that little space that I want to find the area for. So looking at our space here, we can see that our upper function happens to be, again, that x-axis, which is 0 minus, and we've got our x cubed minus 4x, which is our function, and we're going to try and just integrate that whole space for us. So taking our rules and just saying, I've got my integral function, I'm going to take that zone and I'm going to just rewrite it so that I end up with just the negative, which is right there, multiplying it out, because I end up now with that. Once I expand and multiply out that negative sign, that's why I end up with both of those two signs, just so you know, it doesn't just pop out of nowhere. Once I'm here, I've actually gotten my area to the space where I can now integrate it. So I'm going to just apply the rule 2. If you remember, we've got our formula sheet. Remember the formula sheet that we've been working with? So we're just going to apply one of our rules, which is this one right here, where you're going to integrate an x value to a power. So once you do that, you end up with your negative still there, x to the power 4 over 4 plus your, now if I do it in 2 steps, which I want to do just to show you where we're going, you've got your x squared over 2. And because you've applied the integration rule, you can now take away the integral sign, keep the boundaries in place. If we want to rewrite our space, I'm going to move this page now off the screen and just move him that way. Okay. So this is where we stopped. So I'm going to just go right all the way back to the top of my page. Just for continuity, let me just put this guy now in a slightly different form. I'm going to take this 4 and let him be that quarter, and I end up with my x to the power 4 plus. Now this is just one little catch there to think about. If I simplify my space just a little bit and I say, here's my common factor, I end up with a slightly smaller number, and in fact I've got positive 2x squared. I keep my boundaries still because I haven't actually done the substitution. So that's where I am right now. Once I've gotten to that spot, I have to do the upper boundary substitution, subtract by the lower boundary substitution. So if we take a look and we just put that all in, try not to trip over ourselves. As we put down, that 2 goes into the space right here. To the power 4 plus. This x then gets replaced also by the 2, and I'm squaring it. Now this entire space, then because I'm working in that little boundary, I'm then going to apply it to my same function, and I've got my negative quarter, and this time I'm substituting my 1 to the power 4 plus 1 squared. So that's my number on that point. So I've substituted all the values. Now it's possible for you to, from left to right, put all this into your Texas or your Casio or your Sharp calculator, but it's often better just to break your sum down just a little bit further so you don't end up getting things muddled. So once you work them out a little bit finer, you end up with a subsection. So there's that minus again, and you've got that negative a quarter plus 2. Now in the slightly simplified form, you eventually end up with a final answer of 2 1/4 units squared for that little space which we've just calculated.